Good day, students. Today we're going to discuss another set of differentiation rules. This time, we're going to have the derivative of trigonometric functions. Before we start the discussion, let me present the summary of formulas. The derivative of sin u is equal to cosine u times du. The derivative of cosine u is equal to negative sin u times du. The derivative of tangent u is equal to secant square u times du. The derivative of cosecant u is equal to negative cosecant u cotangent u times du. The derivative of secant u is equal to secant u tangent u times du. And finally, the derivative of cotangent u is equal to negative cosecant square u times du. For example, let's have the derivative of sin u. So this is the formula. Find the derivative of y equals sin x squared plus 3x. First, let us represent u. U equals x squared plus 3x. So du will be equal to 2x plus 3. Let us apply the formula. Just substitute u and du. dy over dx is equal to cosine u times du. So dy over dx will be equal to cosine x squared plus 3x times 2x plus 3. Or, let us express our answer as dy over dx equals 2x plus 3 times cosine x squared plus 3x. This will be our final answer. The reason why we wrote 2x plus 3 first, to avoid confusion, because in the second line of the solution, it will look like x squared plus 3x will be multiplied to 2x plus 3. But that's not the case. Because here, the argument is cosine and the u is x squared plus 3x. So better to write 2x plus 3 before cosine x squared plus 3x. So our final answer will be dy over dx equals 2x plus 3 times cosine x squared plus 3x. Now let's have the derivative of cosine u. This is the formula. The derivative of cosine u is equal to negative sin u times du. For example, find the derivative of y equals cosine 2x cubed minus x squared. Represent u. U equals 2x cubed minus x squared. So du is equal to 6x squared minus 2x. Apply the formula. Dy over dx equals negative sin u times du. Substitute u and du. So this will become dy over dx equals negative sin 2x cubed minus x squared times 6x squared minus 2x. Express our final answer this way. Dy over dx equals negative 6x squared minus 2x times sin 2x cubed minus x squared. Again, this is our final answer. 6x squared minus 2x was written before sin 2x cubed minus x squared. I already told you the reason from our first example. Next, let's have the derivative of tangent u. This is the formula. The derivative of tangent u is equal to secant square u times du. For example, find the derivative of y equals tangent sin x. Represent u. U is equal to sin x. So du is equal to cosine x. Apply the formula. Dy over dx equals secant square u times du. Substitute u and du. So this will become dy over dx equals secant square sin x times cosine x. As you can see, our u is sin x and our du is cosine x here. Just like what we did in previous examples, write du after cosine u. So our final answer will be dy over dx equals cosine x secant square sin x. This is our final answer. Now let's have the derivative of cosecant u. The formula is the d of cosecant u is equal to negative cosecant u times cotangent u times du. For example, find the derivative of y equals cosecant ln x. Represent u. U is equal to ln x. The derivative of ln x is equal to 1 over x. Then apply the formula dy over dx equals negative cosecant u cotangent u times du. Substitute the values of u and du. So this will become dy over dx equals negative cosecant ln x cotangent ln x times 1 over x. As you can see, our u is ln x and our du is 1 over x. Our final answer will be dy over dx equals negative 1 over x times cosecant ln x cotangent ln x. Now let's have the derivative of secant u. The derivative of secant u is equal to secant u tangent u times du. For example, find the derivative of y equals secant cosine x. Our u here is obviously cosine x. So du is equal to negative sin x. Then apply the formula dy over dx equals secant u tangent u times du. Substitute the values of u and du. So this will become dy over dx equals secant cosine x tangent cosine x times negative sin x. Or dy over dx equals negative sin x secant cosine x tangent cosine x. This is our final answer. Now, let's have the derivative of cotangent u. The formula is the derivative of cotangent u is equal to negative cosecant square u times du. For example, find the derivative of y equals cotangent e to the x, or y equals cotangent e raised to 2x. U is equal to e raised to 2x. Du is equal to 2 times e to the 2x. Now apply the formula dy over dx equals negative cosecant square u times du. Substitute the values of u and du. Dy over dx is equal to negative cosecant square e raised to 2x times 2e raised to 2x. Or dy over dx equals negative 2e raised to 2x cosecant square e raised to 2x. This is our final answer. Now, I'll give you some exercises to answer. Find the derivative of the following. Number 1, y equals sine 3x plus cosine 2x. Number 2, y equals tangent x plus cotangent e raised to x. And for items number 1 and 2, here on the first term, of number 1, you're going to apply the rules of the derivative of sine u. For number 2, or for the second item, you're going to apply the rules, or for the second term, you're going to apply the rule for the derivative of cosine u. On number 2, the first term, you're going to apply the rule for the derivative of tangent x, or for the derivative of tangent u. For the second term, you're going to apply the rule for the derivative of cotangent u. For you to determine the derivative of e to the x, first you have to study the derivative of e to the u. For number 3, xy plus x second x equals cosine y. For number 4, 1 plus y squared equals x squared cosine y. For items number 3 and 4, you are going to apply implicit differentiation. If you need more time, just pause this video. Then after you have solved these items, check whether your answer is correct. I hope you're going to get the same answer. Perform the correct solutions and it will lead you to the right answer. Good luck. Here are the answers. For number 1, y prime is equal to 3 cosine 3x minus 2 sine 2x. For number 2, y prime is equal to second square x minus e to the x cos second square e to the x. If your answer is expressed as dy over dx instead of y prime, that's okay. For number 3, the answer will be y prime equals negative y plus x tangent x plus 1 times second x all over x plus sine y. And for number 4, your answer will be y prime equals 2x cosine y over 2y plus x squared sine y. I hope you learned something today. Thank you very much for listening.